Okay, let's find the slope and deflection at the free end of a cantilever beam loaded as shown in this figure. Now there's a slight changes in this diagram. Now the EI values is changing for the first 2 meter and the last 2 meter. So let me call this part as C. So this part is 2EI and this part is EI. So as we discussed earlier, so first we'll draw the elastic curve or the deflection curve. So this is a cantilever beam. When it is loaded, it will deform in this shape. There is no change. So we want the slope at B. So let us draw the elastic tangent. This is what is theta B and this is what is delta B. So this is B and this is what is B dash. So then we'll draw bending moment diagram. So how is the bending moment diagram? At the C, the bending moment is 10 into 2 is 20, linearly increases. Then, so this is 20 kilonewton meter. Then what will happen? It increases linearly at A. So the value is 10 into 4, 40. So this is 40 kilonewton meter. So this is what is the bending moment diagram. So A, C, B point. Now as the EI value is changing, let's draw the M over EI diagram. We will be using the second method. So let's draw the M over EI diagram. So what's the value of EI for the region CB? It's EI, whereas the value of EI for the region AC is 2EI. So we need to draw M by EI. So the bending moment at C for the region CB at C is 20. So it is 20 by EI. There is no change here. But for the region CA, it is 2EI. So what I need to do? I need to divide by the same value by 2. So 20 by 2 is 10 EI. So it decreases here at point C. Then once again it increases because it is 40. So 40 by 2 is once again 20. It is 20 by EI. Okay, it's 20 by EI. Now, so this is what is M by EI diagram. Okay, so let's split the area. So this is the region 1, this is region 2, and this is what is the region 3. Now this is 20 by EI whole. So this region is 10 by EI and this region is also 10 by EI. Because this is 10 by EI, so this is 10 by EI. Now we need to find slope at B. We need a two points. Theta BA is equal to area of M over EI diagram between B and A. So what is the answer? Which is equal to, so we need to take the area of all the region. So what is the region first? Half into base into height 10 by EI plus next region is 2 into 10 by EI plus last region half into base into height. Height is 20 by EI. Region third 20 by EI. So if you work out, so what you will get is 30, 50 by EI. So this is what is the slope at B. You know that, which is equal to theta B minus theta A. Theta A is 0, which is equal to theta B. So you can write here theta B is equal to. Now let's find the deflection. To find the deflection, you know, delta B is equal to moment of M by EI diagram between B and A about B. So you need to take the moment of all the diagram about B. So let's do it once again. Half into base into height. So you need to take the moment. So for the region, it's a triangle. So for the triangle, you know, from the apex it is 2/3. 2/3 of 2 plus 2 plus second region is rectangular. So it is 2 into 10 by EI into 2 by 2 plus 2. And the last region, once again triangle, half into base into height. Height is 20 by EI into 2/3 of 2. So if you solve these things, you will get 120 by EI. So this is what is the deflection. This is what is the deflection at B.